Hello, this is your special education virtual content specialist with the 6th grade math lesson for June 17th. This lesson, like all other lessons, can be found on TeachHub, where we provide the title, the focus question, and the learning objective, including the standards and objectives for each lesson. We also provide guidance for using this resource, including instructional and technology guidance, implementation guidance for each slide in the lesson, guidance for assessment during instruction, guidance for summarizing, and general methods of engaging with students with disabilities and multilingual learners. 6th graders are continuing to work on Unit 8, Datasets and Distribution. Day 32, Box Plots Part 1. How can box plots help us summarize distributions? The introduction provides students with the birth weights in ounces of all the puppies born at a kennel in the past month. What do you notice and wonder about the distribution of the puppy weights? To support students with disabilities, you can provide them with sentence starters that say, I notice or I wonder, or you can give them a T-chart with noticings on one side and wonderings on the other side. Sample responses may include, I noticed the median birth weight is 17 ounces. I notice the median looks like it's the same as the mean. I notice almost a third of the puppies weigh 18 ounces. I notice there are no gaps in the data or values that are very far from the center. I notice that there are 25 puppies. Students may wonder if the IQR is less than 1. I wonder if a box plot could be used to represent the data. I wonder if a dot plot could be used to represent the data. The introduction continues with an activity synthesis. So while students may notice and wonder about many aspects of the data set, focus the discussion on observations and questions about the features, center, and spread of the distribution. Question 1. Can you use the dot plot to answer what you wondered about? Question 2. Did you anticipate the distribution to have this shape? Question 3. What do you notice about the distribution here that you did not notice in the table? Question 4. Which representation of the data, the table, or the dot plot allows you to see the center and spread of the distribution more easily? Why? Question 5. Which representation allows you to find the mean more easily? What about the median? The answers to questions 1 through 5 will vary depending on what the students had noticed and wondered. For this slide in the Explore, students are introduced formally to the box plot. A box plot is a way to represent data on a number line. The data is divided into 4 sections. The sides of the box represent the first and third quartiles. A line inside the box represents the median. Lines outside the box connect to the minimum and maximum values. For example, this box plot shows a data set with a minimum of 2 and a maximum of 15. The median is 6, the first quartile is 5, and the third quartile is 10. For slide F in the Explore, students are presented with the following situation. 20 people participated in a study about blinking. The number of times each person blinked while watching a video for 1 minute was recorded. The data values are shown here, in order from smallest to largest. To support students with the next few slides of the Explore, have them pair up with their previously identified peer tutors and allow students who struggle with fine motor skills to dictate creating the box plot as needed. For students who struggle with executive functioning, you want to eliminate barriers. So you might want to chunk this task into more manageable parts, such as presenting one question at a time, which will aid students who benefit from support with organizational skills in problem solving. This is an example of what the dot plot should look like. For question 1B, you're asked to find the median, quartile 2, and mark its location on the dot plot. That value would be 15 blinks, since it is the average of the 10th and 11th values. Part C asks students to find the first quartile and the third quartile, mark their locations on the dot plot. The first quartile is 12 blinks, which is the average of the 5th and 6th values, and the third quartile is 21 blinks, which is the average of the 15th and 16th values. For question D, it asks what are the minimum and maximum values. Those are 3 and 51 respectively. The minimum data point is 3 blinks, and the maximum data point is 51 blinks. For slide I, it states a box plot can be used to represent the 5-number summary graphically. Let's draw a box plot for the number of blinks data. On the grid above the dot plot, draw a box that extends from the first quartile to the third quartile. Label the quartiles. So the first quartile will be at 11, and the third quartile would be at 21, and there is the box for part A. For part B, it should say at the median Q2, draw a vertical line from the top of the box to the bottom of the box and label the median. So if you recall, the median is at 16. It should also say from the left side of the box Q1, draw a horizontal line, a whisker, that extends from the minimum of the data set. On the right side of the box Q3, draw a similar line that extends to the maximum of the data set. And now we're going to connect it. For question 3, it states you have now created a box plot to represent the number of blinks data. What fraction of the data values are represented by each of these elements of the box plot? A, the left whisker. The answer is 1/4. The left whisker contains all the data values from the minimum to quartile 1. There are 5 points, which represents 1/4 of the data. B, the box, 1/2. The box contains the values in between the first and third quartile. There are 10 values, which comprises 1/2 of the data. C, the right whisker. The answer is 1/4. The right whisker contains all the data values from quartile 3 to the maximum. There are 5 points, which represents 1/4 of the data. To synthesize the activity, you can discuss these 2 questions. Question 1. If you just look at the box plot, can you tell what any of the data values are? A sample response from a student would be only the minimum and maximum values. Question 2. If you just look at the dot plot, can you tell where the median is? Can you tell which values of the data make up the middle half of the data? Can you tell where each quarter of the data values begin and end? Students should articulate that it is possible to tell, but it's not straightforward and it requires some counting, which would lead to discussing the benefit of a dot plot versus a box plot. So the focus of the activity was constructing the box plot and understanding its parts, rather than on interpreting it in context. If students seem to have a good grasp of the drawing process and what these parts entail and mean, consider asking them to interpret the plots in the context of the research study. You can ask students, suppose you are the scientists who conducted the research and are writing an article about it. Write 2 to 3 sentences that summarize your findings based on your analyses of the dot plot and box plot. You can also review with students how a box plot is made. So a sample response would be, the box is a rectangle with the left side at Q1 and the right side at Q3. The line inside the box is the median. The whiskers on the sides extend to the minimum and maximum values of the data set. What does the box plot tell you about the shape, center, and the spread of a distribution? The median is the line in the middle, which tells you about the center. The IQR is the width of the box in the middle, which tells you about the spread. You can also tell if the distribution is roughly symmetrical. Why is it useful to use a dot plot and a box plot together? The dot plot shows the actual data values, while the box plot tells the story of the data in fourths. How can the box plot be helpful in comparing 2 data sets? You can compare the minimum and maximum values, where the median falls, and how the data is distributed among the 4 quarters. For the summary, students are responding to the focus question, how can box plots help us summarize distributions? You can provide students with a sentence starter, as shown here. Box plots can help us summarize distributions by blank. If students are struggling with the lesson, please guide them to this support video for extra help. For additional practice, students can complete the Open Up practice problems, iExcel Grade 6 GG.23 box plots, Khan Academy Creating Box Plots, or Engage New York Module 6 Lesson 14 problem set. This lesson was adapted utilizing illustrative mathematics and Open Up resources. Please visit these sites to support digital learning. If you have any questions, reach out to a virtual content specialist. Thank you.